Yes, dear children, let me discuss question number 31 of your exercise. Okay. Now here, what are all the things that you need to remember is lowest ionization enthalpy you will find with alkali metals, because alkali metals from left to right, when you go, the size is shrinking. So the first element, that is alkali metal, will have the biggest size. So ionization enthalpy is the lowest. Bigger the size, easy to remove. So lowest ionization enthalpy will be that of alkali metals. Then difference between first ionization enthalpy and second ionization enthalpy will be minimum for second group elements. Okay? Why? Because, say for example, Mg, it loses one electron to become Mg plus. The configuration is 282 here. After losing one electron, it becomes 281. It is still having one valence electron. So that Mg plus will lose one more electron to become Mg2 plus to get the configuration of 8. Okay. Now since Mg plus is unstable, it will lose one more electron to become Mg2 plus, which is getting the stable state. So this is your first ionization enthalpy and this is your second ionization enthalpy or energy. So the difference between the two will be minimum in the case of second group elements, because after becoming a di-positive ion only, it will get the stable electronic configuration. Now if you compare it with that of, say, sodium. Sodium is losing one electron to become Na plus. Configuration is 281 and it has got 28. Now if sodium has to lose one more electron to become Na2 plus, then the amount of energy required to remove the second electron from a stable electronic configuration will be very, very high. Okay, so in that case, this is your first ionization enthalpy and this is your second ionization enthalpy, and the difference will be too high, because to remove an electron from a stable electronic configuration, you need to supply a lot of energy. So the difference between the two will also be very, very high. Right? So in the case of alkali metals, the difference between the two will be high, whereas in the case of second group elements, the difference between the first and second ionization energy will be nominal, or it will be minimum. Okay? So this is another guess that you have to remember. Then the third one is noble gases have positive electron gain enthalpy, because noble gases have fully filled configuration. They neither gain electron nor lose electron. So their delta Heg, that is electron gain enthalpy, will be positive. Okay, it cannot gain an electron. If at all you have to give an electron, then you have to forcibly give it. That means you have to supply energy. So you say delta Heg is positive for noble gases. Then halogens, they have the largest, or you can say the most negative electron gain enthalpy. Halogens have the most negative electron gain enthalpy, because F plus electron becoming F minus. Now F is having 2,7. After gaining an electron, it becomes 2,8, which is a stable electronic configuration with the release of energy. Remember, energy released means delta H negative. Okay, or you can say for exothermic reactions, energy is released, and for such reactions delta H will be negative. So you say exothermic reactions will have negative delta H. So this gaining of electron by halogens is a spontaneous reaction where energy is released. So energy released means delta H is negative. And halogens, they have the most negative electron gain enthalpy. So these four things you have to remember. Now apart from this, one more I can say, that is the first element of every group will preferably form a covalent compound, because the first element in a group is the smallest in size, and if the size is small, tendency to lose is difficult. So becoming an ion is also difficult. A positively charged ion cannot be made from the smallest size atom. So first element of every group will preferably form a covalent compound. Okay, so this also you need to remember. Say for example lithium, beryllium, boron. These are the first elements of every group. First element of first group, first element of second group, first element of 13th group. So like that, these are all the first elements, and they will preferably form covalent compounds. Okay, because they are having the smallest size and high ionization enthalpy. So they will preferably form covalent compounds. Supposing if you consider Li, and if it is reacting with say any halogen, say X, then it will form LiX. X may be here either fluorine or chlorine or bromine or iodine. So this LiX will be preferably covalent in nature. So these are the 4 points that you need to understand before you go to this particular question. Now this question says, we are not able to see it. First element of every group will preferably form a covalent compound because of small size and high ionization enthalpy. Now what is the question that we are discussing is, you have been given 1, 2, 3, 4, 5, 6. 6 elements have been given, and for these 6 elements, first ionization enthalpy and second ionization enthalpy has been given, and also delta H Eg is also given. For the first one, it is 520, 7300 and minus 60. All these are in terms of kilojoule per mole. This is the unit for all the 3. Then you have 419, then 3051 minus 48, and then what you have 1681, 3374, and this minus 328, then 1008, 1846 minus 295, then you have 2372, 5251, and then this is plus 48, then 738 and 1451, this is minus 40. So this is the table that is given in question number 31. Now what you have to find out? You have to find out the least reactive element. Which is the least reactive element in the periodic table? It is nothing but noble gas because it's having stable electronic configuration. And I have already told you that which will have positive electron gain enthalpy. Noble gases, they have positive electron gain enthalpy, and that is the least reactive element in the periodic table. Now you have to see which is having positive electron gain enthalpy, which is this plus 48. That means your answer is 5. Then number 2, they are asking the most reactive metal. Now what I told you, if the ionization enthalpy is the lowest, then they are alkali metals. And if the difference between first and second ionization enthalpy is minimum, then probability it will belong to second group elements. Okay, so these two things we saw it. Now let us see in terms of values. Now see here, this is over now, so rule out this. Let us see among the rest. I told you alkali metals have the lowest ionization enthalpy. So lowest means 419 is the lowest, and then you have 520. These two are low ionization enthalpy, and the difference between the first and second is also very high. Here also it is almost, this is 5 and this is 7300. So you can say almost it is 7 times. No, not even 7 times, even more than that. And this is 400 and this is around 3000. So this is around 7 times. This is much more than 10 times. Right? So if the difference between first and second ionization enthalpy, if they are very high, then in all probability 1 and 2, they are more reactive metals. And since both of them are very low, 419 and 520, it's possible that both belong to alkali metals. Right? Now what you know that down the group ionization enthalpy decreases because size is increasing, so ionization enthalpy will decrease. Amount of energy supplied to remove an electron, it becomes easier. So ionization enthalpy decreases down the group. When you say decreases down the group, that means 520 will be on top and 419 will be the next. And you also know that down the group metallic character increases. As the size increases, metallic character also increases because the nuclear attraction for the valence electron will decrease because of the distance, and so it will become more and more metallic. So this 419 corresponding to whichever element, this is more metallic than this. It is something like lithium, then sodium, then potassium. So you may expect that sodium is having lesser ionization energy than lithium, and sodium, it is much more reactive than lithium. So the most reactive metal, if you consider, it will be 419. That means your answer is 2. Now come to the third part. The question is the most reactive non-metal. The most reactive non-metal. Which is the most reactive non-metal? Obviously it is halogen. And halogen, what do you know? They will have the most negative delta H Eg. Now among the given, which is having the most negative delta H Eg, this is minus 328. That means corresponding to 3. So the most negative non-metal is 3. Then fourth question he is asking you, the least reactive non-metal. The least reactive non-metal. What could it be? Now minus 328, minus 295. Now first and second, they are metals, so they are not metals, it's stable. Then this 3 is the most negative, so this is the most reactive non-metal, that is halogen. And then this is noble gas, so this is also not a non-metal. Then 6, it is 738 and 1451. That means it is just double. Where did we see that the difference is minimum? In the case of alkaline earth elements. So this is not also not a non-metal. So out of these two you have to choose now. So it is the least reactive non-metal is 4. Then the next one he is asking, metal which forms a binary halide, of the form MX2. That means the valency of M is 2 and that of X is 1. You know halogen ki valency 1 hai. And this 2 is belonging to showing the valency of metal. If the valency is 2, what did I tell you? The sixth one, where the difference in ionization enthalpy is not large, it is in all probability it is a second group element. And here we are talking about M having valency 2. That means the answer here is 6. The metal which forms a binary halide is 6, where the first and second ionization enthalpy, they do not differ much. Then the last question is the metal which forms predominantly a stable covalent halide. A stable covalent halide of the form MX. Now here you see MX, when you write, the valency of M is 1 and that of X is also 1, because you know halogen, the valency is 1. So if it is MX, the formula, that means valency of M is also 1. That means it belongs to first group. Now the metal which forms predominantly a stable covalent halide. Now here I told you, first element of every group will preferably form a covalent compound, right? Now here, when you see the elements first and second element, they are having very less ionization energy and they belong to first group, we already discussed. Now what you know that down the group ionization energy decreases. So 419 will be second element and 520 is expected to be the topmost element, because just now we saw ionization enthalpy decreases down the group as the metallic character increases. So here the one which will form a stable covalent halide is that of 1. Okay, so the answer here is 1. That is the answer. So this is how your question number 31 is discussed.